All right. So we decided that quartz was our greatest sediment material because quartz is A, abundant, B, chemically stable, and C, durable. Chemically stable just means it doesn't react with a lot of stuff, so it doesn't get eroded by acids or bases or other materials that easily. It's pretty solid. So if we look at a lot of rock, so if I look at a lot of different rocks and materials, you see little structures that look like crystals in them. That is all quartz. So if we look at most rock that you pick up, you will see some form of quartz in it. Not all of it, but most of it. All right, and we went over this slide. We determined that as rock matures, or as sediments mature, they sort. Some sort of moving around happens. We call it sorting. So they move around, they resituate themselves, they compact, so they fill in the little gaps as much as they can. Content of the clay decreases. Now, if we think of this, Chad, if I take a handful of mud from the bottom of the water, or mud and rock and dirt, and I run it under some water, what's going to happen to the dirt? The rocks are going to stay, aren't they? And the dirt is going to go? The same thing happens here. As these rocks sort, the clay kind of filters out, like you would if you were sifting for gold. And then over time, as these rocks hit each other, they're constantly grinding around, moving around, these sharp edges wear off. And we had this slide on Thursday, so you should have it. All right, so distribution of the sediment. So where do we find it? And you had these terms. We went through these already. Neritic is near shore. Those are going to be your beaches, your continental shelves, your turbidites, and your glacial rafted debris. So let's look at what each of those areas are. Everybody know what a beach is? Everybody not know what a beach is? All right. Continental shelf. Basically what a continental shelf is the area on a continental plate that is below water. So we're on a continental plate right now. If you go off of the coast, so off the east coast, off the west coast, off the south, you're still on that continental plate. But there will be a section of that continental plate that is underwater. That is a continental shelf. A lot of sediment gets deposited there from rivers and so forth. That's actually where it generally gets deposited right away. And what it might create is a turbidite. So all this sediment builds up, builds up, builds up, builds up. What happens on the mountains is all that snow builds up. You guys have seen the mountains is all is snow. It keeps snowing down, keeps snowing down, keeps snowing down. What happens to the side of the mountain? What do you get after a while? You get avalanches. That's what a turbidite is. It's an underwater avalanche. So all that sediment builds up, it builds up, it builds up. It keeps piling on top of one another. Eventually, it falls down. It like erodes down. So the turbidite is just an underwater avalanche. That's all that is. And then a glacial rafted debris, that's debris transported by ice, big ice plates, glaciers. And then as we go out deep, pelagic, the deep ocean floor. So neritic is near the shore. Pelagic is your deep ocean. You have these large masses of flat area, like deserts. Think of them as like deserts. If you go on the other side of the Rocky Mountains, it's a long flat desert, isn't it? That's what makes up most of Utah. Think of the Sahara. Just this long flat plain that goes nowhere. Or actually think of Iowa. You didn't laugh. I was waiting for him to laugh. Anyway, there's this... In the ocean, you have these long flat areas in between subduction zones and ridges. Those are abyssal plains. They're just these long flat areas in the ocean. So on those abyssal plains, you get clay particles that settle. That's abyssal clay. That's all that is. All right, so these are the distribution. Now we're going to look at biogenous. These are the fun ones.
At this time, all students are required to be in class.
So, origins of biogenous sediment. So, organisms, some organisms have hard materials associated with them. Do we have hard material associated with us?
Yeah.
What is it? Bone. Bone and teeth. So, in the ocean, you have animals that produce shells or exoskeletons, such as shrimp and crabs and so forth. Well, when these animals die, these materials are left behind. Obviously, when an starfish eats a clam or a mussel, they don't eat the shell, they just eat the meat that's inside the clam. Same with a shrimp. When you eat a shrimp, do you eat the outer skeleton?
No.
No, you don't. You just eat the inside. You leave the outer skeleton. Well, when marine animals are eaten, these pieces are left behind. So they sink to the bottom of the ocean. These are macroscopic shells. Macros means big. So your bone, your teeth, your large shells that you can see. These all fall to the bottom. Has anybody ever been to the Mississippi River? I used to work on the Mississippi. I worked at a camp. I used to run a waterfront. The bottom of that waterfront, we had to wear shoes at all times because it was oyster shells. So all these shells, these aren't oyster shells, but they kind of look similar. So they were oyster shells, and oyster shells are razor sharp. So if you do not wear shoes, you basically cut your feet up. So same thing is with the ocean floor. There's a lot of just random shells around. Now after a while, all these shells will break apart, and they'll break into smaller and smaller pieces, and they'll actually become rocks and various small parts of the soil. Well, you also have microscopic tests. Tests just mean shell. So these are microscopic shells, like coatings. They might not be classified as a shell, but it's like a microscopic encasement. That's what tests are. So test just means shells. That's all that you're going to hear this word, test, T-E-S-T. It's not like a written test that you take. It's just another word for shells, is all it is. So you have microscopic shells. Microscopic means really, really small. You have to use a microscope to see it. That's why it's microscopic. So at least 30% of these shells, these microscopic shells that you can't see, are composed of a material called biogenous ooze. Sounds cool, doesn't it? Biogenous ooze. So 30% of those shells for these microscopic organisms is made from biogenous ooze. The other 70%, or right around 60%, is made from minerals. Like the minerals calcium, or all the minerals that you normally think of for rocks. But 30% is biogenous ooze, and we're going to learn what biogenous ooze is in a second. What do you think biogenous ooze is?
Liquid thing.
Anybody have a guess? No?
Okay, whatever.
Well, let's go through it. Now we have some chemistry in here. So, first part. So these shells, these microscopic biogenous shells, are composed of two main chemical compounds. First one is silica. Can anybody say what this actually is, the full name for it? What is that? Silica is the short name. Can anybody read that? SiO2? What is Si? Silicon. 2 is silicon dioxide. Yep.